Let's discuss some special simple graph. A graph without multiple edges and loop called as simple graph, and maximum number of edges possible in a simple graph equals to nc2. Combination of n and 2 is equals to n factorial divided 2 factorial into n minus 2 factorial. So after simplification we'll get n into n minus 1 divided 2. So n factorial we can write as n into n minus 1 into n minus 2 factorial, and 2 factorial is simple 2 multiplication n minus 2 factorial. So n minus 2 factorial will be cancelled. We'll get n into n minus 1 divide 2. So maximum number of edges possible with n vertex equals to n into n minus 1 divide 2. And maximum number of simple graph possible with n vertex equals to 2 power number of edges, or we can say 2 power n into n minus 1 divide 2. If edge is given, suppose number of edges is m, then number of simple graph possible equals to c n into n minus 1 divide 2. This is maximum number of edges, and m. We'll use all these formula in examples. Now several classes of simple graph. First I will discuss complete graph. If every vertex are adjacent to every other vertex, then it's a complete graph. So a complete graph on n vertex denoted by kn is a simple graph that connects exactly one edge between each pair of distinct vertices. This is a simple graph, so multi-edge and loop are not allowed. There should be exactly one edge between each pair of distinct vertices. A simple graph for which there is at least one pair of distinct vertices are not connected, it's called as not complete. If every pair are connected, then this is complete graph, and if at least one pair is not connected, it's called as non-complete. In complete graph, degree of each vertex equals to n minus 1. As every vertex is adjacent to every other vertex, so degree of each vertex is n minus 1. Suppose there are two vertex, then degree of each vertex will be 1. Suppose there are 3 vertex, then degree of each vertex will be 2. And number of edges in kn equals to nc2, that is equals to n into n minus 1 divide 2. So maximum number of edges possible in a simple graph is equals to number of edges possible in a complete graph. Complete graph is also type of simple graph. So maximum number of edges in simple graph is n into n minus 1 divide 2, and number of edges in complete graph equals to n into n minus 1 divide 2. So examples of complete graph starting from n1 till 6. So k1, just one vertex is there, degree will be 0. Then k2, 2 vertex are there, so degree will be 1 for each vertex. So this vertex degree is 1, this vertex degree is also 1. Now k3, 3 vertex are there, so each vertex is adjacent to 2 vertex, so degree of each vertex will be 2. So let it A, B, C. A is adjacent to B and C, B is adjacent to A and C, C is adjacent to A and B. Next K4, 4 vertex, so degree of each vertex will be 3. Just see degree of each vertex are 3. Next K5, 5 vertex, degree of each vertex are 4. Next K6, 6 vertex, degree of each vertex are 5. So every vertex are adjacent with other 5 vertex. Next type of simple graph is cycle. In cycle, every vertex are adjacent to its next vertex. A cycle Cn, n should be greater than equals to 3. For 2 vertex or 1 vertex, we can't create a cycle. Consists of n vertex like b1, b2, b3 till bn, and edges are b1 to b2, b2 to b3, bn minus 1 to bn, bn to b1. Now cycle examples. This is C3, a cycle consisting of 3 vertex. Each vertex are adjacent to next vertex. Let it be b1, b2, V3. So there is a edge between V1 to V2, there is a edge between V2 to V3, then V3 to V1. Next C4, it is a cycle having 4 vertex. So every vertex are adjacent to next vertex and every vertex have degree 2. Next C5, there are 5 vertex, every vertex have degree 2 and every vertex are adjacent with the next and previous vertex. Then C6, there are 6 vertex and degree of each vertex equals to 2. So in case of cycle, degree of each vertex equals to 2. It's adjacent to next vertex and the previous vertex. Like for V2, V2 is adjacent to V1, also V3. Vn is adjacent to Vn minus 1, also with V1. Hence every vertex degree is 2. Next is wheel graph. If we are adding one vertex in between a cycle and adding the edges from that vertex to every other vertex, then that's a wheel. So to obtain a wheel Wn, when we add an additional vertex to a cycle Cn for n greater than or equals to 3 and connect this new vertex to each of the n vertex in Cn by new edges, then that's a wheel. Now examples of wheel are this. This is W3. There are 4 vertex including this center vertex. So there are 3 outer vertex that create a cycle and we are adding this center vertex and there are edges from this to every other vertex. Next W4, there are 5 vertex including this center vertex. So there is edges from the center vertex to every other vertex. Next W5, there are 6 vertex. It's C5 and we are adding one vertex in between that C5 and adding edge to every other vertex and we can get the wheel 5. Next W6, wheel of 7 vertex. So in C6, when we are adding a vertex in center and adding the edges to every other vertex, we are getting wheel 6. Next is bipartite graph. If we are partitioning set of vertex into 2 parts and there are edges between the 2 parts, then that is a bipartite graph. So a simple graph G is called bipartite if its vertex set V can be partitioned into 2 distant set V1 and V2 such that every edge in the graph connect a vertex in V1 and a vertex in V2. Suppose this is V1, this is V2, then there are edges from V1 to V2. When this condition holds, we call the pair V1, V2 a bipartition of the vertex set V of G. Now one example 4, C6 is a bipartite as shown in the figure. This is C6. This is V1, V2, V3, V4, V5 and V6. So there are edges from V1 to V2 and V1 to V6. So what we can do, we can make partition like V1, V3, V5 one group, then V2, V4, V6 another group. So it's a bipartite. So there is a edge from V1 to V2, V1 to V6. Now for V2, V2 is adjacent to V1 and V3. So there is a edge from V2 to V1 and V2 to V3. Then there is a edge from V3 to V2 and V4. So as we can bipartite, as we can partition this set of vertex into 2 parts and there are edges from V1 to V2, hence C6 is a bipartite graph. Now theorem 4, a simple graph is bipartite if and only if it is possible to assign one of 2 different color to each vertex of the graph so that no 2 adjacent vertices are assigned the same color. Let's take an example of C6. So V1, V2, V3, V4, V5, V6. This is a cycle. If it is possible to assign one of 2 different color to each vertex of the graph so that no 2 adjacent vertices are same color. Here you can see no 2 adjacent vertices are same color. V2 adjacent are green color. Then B4 adjacent are green color. Like B5 adjacent are blue color. So no two adjacent are same color. Then this is a bipartite. Suppose we'll create a bipartite of C6 like B1, B3, B5, B2, B4, B6. So here B1 is green, B3 is green, B5 is green, and B2 is blue, B4 is blue, B6 is blue. So one side vertex is one color, another side vertex is another color. We can assign two color, one color to one set, another color to another set. Then this is a bipartite graph. Mainly it is saying if you can make two partition of vertices, then this is a bipartite graph. Next is complete bipartite graph. If one vertex is adjacent to all other vertex of other group, or you can say other vertex set, then this is a complete bipartite graph. Now definition, a complete bipartite graph KMN is a graph that has its vertex set partitioned into two subsets of M and N vertex respectively. So one set contain M vertex, another set contain N vertex with an edge between two vertex if and only if one vertex is in the first subset and the other vertex is in the second subset. So there are edges from one vertex to every other vertex in the second subset. And remember, complete bipartite graph is not same as complete graph. So KMN is complete graph if MN equals to 1. Like K11. This is a bipartite graph, or you can say this is a complete graph of two vertex. So complete graph and complete bipartite graph are equal when there are two vertex. And in case of bipartite graph, there are M plus N vertices and M multiplication N edges. Now these are some examples. This is K23, one group contain two vertex, other group contain three vertex. Let this is A, B, this is 1, 2, 3. So A is adjacent to all 1, 2, 3, B is adjacent to all 1, 2, 3. 1 is adjacent to all A, B, 2 is adjacent to A, B, 3 is adjacent to A, B. So you can say one vertex is adjacent to every other vertex of other subset. So here number of vertex equals to 2 plus 3. There are 5 vertex and number of edges equals to 2 into 3. It's 6. There are 6 edges. 1, 2, 3, 1, 2, 3. Next K33. So there are two partition. One contain 3 vertex, other contain 3 vertex. There are 6 vertex. 3 plus 3, 6 vertex, and there are 3 into 3, 9 edges. So every vertex is adjacent to 3 vertex of other group. Next K35. One subset contain 3 vertex, other subset contain 5 vertex. There are total 3 plus 5, 8 vertex, and there are total 3 multiplication 5, 15 edges. This is our first subset, this is our second subset. So every vertex of our first subset are adjacent to all 5 vertex from second subset. Next is K26. So total there are 2 plus 6, it's 8 vertex. In total 2 multiplication 6, 12 edges. So this is one subset, this is another subset. These two vertex are adjacent to all 6 vertex from other group. So just mark, in bipartite graph there are no edges between the same group. There are edges from one group to other group. Like there are no edges between these two vertex, as these two belongs to same group. So there are edges from one group to another group. In today's lecture I discussed complete graph, cycle graph, wheel graph, bipartite graph, complete bipartite graph. In next lecture I will discuss some more examples of this. If today's lecture is helpful for you, please like, share and subscribe. Thank you.